Alright, welcome back to another Make Math Make Sense video. Today we're going through the second lesson in Algebra 2 in the Polynomials unit, the arithmetic unit. Average rate of change of polynomials. And a little review, average rate of change is slope. So we're going to be talking about the slope of 2 points, between 2 points. Okay, here we're given a function, g of t equals negative t minus 1 squared plus 5 over which interval? And that's an important word to note, interval. Interval just refers, it tells you the part of the graph that you're looking between. So I don't know, you could define it as the piece of the graph that you're evaluating, and that piece is always given to you in x values. Cool. And we're looking for the average rate of change, which is an important word. We talked about that a minute ago. This is the slope of those points, and we're looking for when that slope is 0. Cool. And so just to kind of recap, if we have a quadratic and we choose 2 points on that, let's just say the interval starts right here and the interval ends right here, and we drew a straight line, right? We're trying to figure out what would the rise over the run be for those 2 points that we drew that line through. Cool, which would give us a slope. In this particular one, I don't know exactly what it is, but I know that it's a negative slope, right? I'm gonna show you what it would look like, I guess, if it was a positive, right? If our first point was lower than our second point, so if our beginning interval was there and our interval ended there, we drew a line, this would be a positive slope, right? And then if the slope was 0, which is what we're looking for in this particular problem, that's when the start and the end are even with each other, right? And if these 2 points are even with each other, although we may not know what the x value is, we know that this y value for the left point and for the y point is going to be equal, right? So if it's 4, then this is also 4, right? If it was 5, it'd also be 5. So we're looking for when the two y values are essentially equal. Pretty easy if we use Desmos, to be honest with you. So I'm going to go quickly through this. I'm going to pop open my trusted friend, whoopsies, that's the YouTube channel. Good, and put it right here. And then I'm going to type in this function. Negative, I'm going to use x instead of t. And I don't need to write the function notation for this, it's going to graph it the same. So here's our function. I'm looking for this first interval, so I'm going to type in the interval so we can see it shade for us which part of the graph we're talking about. And so we're talking about the part that's shaded, and we're looking for when the interval begins. So the interval starts right here at -2, -4, ends right here, and you can see coincidentally these two dots are even with each other. So if we drew a straight line through them, those dots would in fact have a slope of 0, and that's evident in the fact that our first y value is -4 and our second y value is -4, so they're even. Don't click these dots up here, these dots have nothing to do with it. Those are just obviously intersecting the x plane. Question number 2, what is the average rate of change? What is the average rate of change over the interval between 1 and 6? So I'm going to go ahead and now we're actually finding the slope, right? We're actually going to figure out what the slope of that line would be if we were to draw a line through the 2 points. So there's our interval, and it's given to us in brackets. It's the same information, just displayed differently. And here's our function I'm going to type in right now. Cool. And so we're looking for where the interval starts, so where that shading begins, where the line enters the shade. So it enters at 1, -8. And I guess yeah, I guess I'm just gonna go ahead and write that in right here. 1, -8. That's the dot we're talking about, and then the dot that we're the end of the interval. Whoops. Zoom out a little bit. Wow. It's somewhere in here, right? There we go. 6, 162. So just really hammer this home. I'm going to take the line away. If we were to draw a straight line through those two dots, we're trying to figure out the slope here, right? And essentially we're just calculating the rise over the run, so how much it rises over how much it runs. And an easy way to do that is just to take the first y value, -8, and subtract it from the second one. Boom, there's our rise. Do the same thing for the x coordinates, and we take the same order, so we took -8, so I'm going to take 1, subtract it from the second x value, which is 6, and just to figure out what that is simplified, I'm going to divide them. Positive 34, and that kind of makes sense. We know it's supposed to be a positive line, and it's obviously rising every 34 on the y for every 1 on the x. Over which interval does the function have a positive average rate of change? Okay, so I'm going to go ahead and just take away these boxes real quick, reset. Our function is x to the third minus 9x. Oh, it's actually the same function, that's funny. And then we're going to put in the interval. So we got -2 is when it starts on the x and it ends on 1. And we're looking for positive. So positive is going to be when the dots go up. So we start at 10 and go to -8. That would be a negative slope. That one's out. Let's change this to -3. Positive 3. Here is where the dot enters and where the line begins in the interval, and here is where it ends. And you can see the y values are the same, so this would be a slope of 0. Let's change this to -1 and this to positive 2. Boom, boom. You kind of get confused with these dots. These ones aren't the ones that are important. Here's where it starts in the interval at 8 for y and goes to -10. Again, those dots are going down, so it'll be a negative slope, some number, which means D has to be our answer, right? We've eliminated all the other possibilities, and that means D is the answer. But just to verify, so it starts down here at -28 for y, and it ends on positive 8. That would be a positive rise, so D is our answer. And our last example, again, we're finding the average rate of change. It's giving us the function, so I'm just going to punch that in real quick. X squared plus 10. I'm going to punch in the interval, -2. I wonder if I typed it in with the brackets, if that would work. -2, comma, -1. Okay, so Desmos is reading it differently than it should. Positive, whoops, -1. Okay, classic. Okay, we know it's a negative slope. And let's just do the simple math. So we got at 14 and we go down to 11, so we've just changed -3, right? We've gone down 3. And if we're at -2 and we go over 1, we've changed 1. -3 divided by 1 is -3. So let's put in our answer as -3. Cool. I guess if I zoomed in to where I knew each box was worth only 1, right here, I could just count the boxes. See how now each box is 1, so I go 1, 2, 3 over 1, right? So you can also, I guess, deduce the slope by just kind of using our old methods that we probably learned freshman year. And that's how you find average rate of change for polynomials. So good luck on that.